Alrighty, welcome back. So this is going to be the second question that I'm going to be solving. Forget about the whole gibberish that I just wrote there, but we're here. So we are given log base 10 of a is equal to 1/3, where a is a greater than 0. Find the value of a, log base 10 of 1 over a, and then b, log base 1,000 of a. Fine. The first thing I notice here, that I need to notice here when I try to solve this problem, is we are given a full logarithmic equation. And I personally do not like working with logarithms. And many of you don't, because they tend to be very annoying and very just annoying as a whole. So what I'm going to be doing is I'm going to try to, given this thing, I'm going to try to change it into a format that is friendlier, something that I can play around with, something that I can work. So I can change it into a power. I can change it into exponents. And luckily, IB actually gives us a way to do it. There's a way to do it, which is using this relationship here. Now, I will observe that this 10 is the same as the A in here. This A is the same as the B in here. And then this 1/3 is the same as the X right here. With that, I can rewrite this whole logarithmic equation as a to the x equal to b. Let's do that. So my a, so I'm going to start with log base 10 of a is equal to 1/3. This is equivalent to 10 raised to what? 10 raised to the power of x, which is 1/3 right here. Sorry about that. Is equal to a, which was my b in this case. Fine, I have done that, and I'm going to keep this on the side because we're going to reuse it later on. But now what this tells me from here is that I know what the value of a is. And you will notice that a has been reused again and again for exercise A and exercise B. So when I try to solve A, this guy here, I'm going to be using the same thing where I'm going to convert this guy, this logarithmic rule, into this exponents. So I'm first going to write it as log of 10 of 1 over a is equal to a certain value x that we're actually trying to find. And the reason I'm writing x here is because I actually know what a is, and I want to find the exact value of this guy here. I want to find what is missing from this equation, which is x, right? So with that in mind, I'm going to write the equivalent again, which would be 10 coming from this a. I'm just doing the whole bridge, this guy here. That was actually bad. And then what is my b? My b is going to be this guy, which is here. But I want my x, so because I want a to the x, so a to the x, literally a to the x, is equal to my b, which is 1 over a. Beautiful. What's the next step? The next step is to solve for x. But we also have a here, which is accordingly maybe like missing, but we already know what a is. So we're going to substitute a into this equation. So it's going to be 10 to the x is equal to 1 over a which is 10 to the 1/3. And then from here, the beautiful thing that we want to do here is because we have a power here, we're an exponent, and both sides of the equation have the base 10. So I need to rewrite this whole equation, this whole side of the equation, the right side, so that I have 10 on top, so that I have an equation that starts with the base 10. And the way I can do it is I observe that 1 over 10 to the 1/3 is actually a reciprocal. That means that I can rewrite this whole thing instead of using 1 over 10 to the 1/3, I can change this power into, I can add a negative sign to that power to make it actually look like the reciprocal, and I get rid of the 10 here, the 1 here on top. So this becomes 10 to the power of x is equal to 10, my base, to the power of negative 1/3. For those of you who have forgotten your rules of reciprocal or multiplicative inverse, this is actually how it works. So now I will observe that both of them have the base 10. The only thing that makes them equal is actually the power. So essentially, what I'm being told, what I can get from here is that x is going to be equal to negative 1/3 if I equate the powers. And that's it for the first question. For the second question, we're going to be doing the same problem. We're going to be doing the same thing, whereby my base is 1,000, 10,000. Oh, sorry, it's 1,000. So I'm going to rewrite it first here. I'm going to write log of 1,000. A is equal to x. Using my formula here, so I have A, which is my base, 1,000, to the x is going to be equal to A. Now, remember, what is A? A is 10 to the 1/3. So I'm going to rewrite 1,000, x to the power of x is equal to 10 1/3 here. Oh my gosh. Perfect. Once again, we need to figure out a way to reduce them to the same base, which in this case is going to be 10 because that's the lowest base we can get from here. So what is 10,000? What is 1,000, sorry. 1,000 is the same as 10 to the power of 3 because 1,000 is 10 times 10 times 10. So what this tells me is that if 1,000 is 10 to the power of 10, I can convert this guy into that and just multiply it and just put it to the power of x. So I have the same base. So I have 10 to the power of 1/3 here. So far, so good? I think so. Now, you need to remember your exponent rules. And I don't know if IB gives you this, but you actually need to remember those exponent rules because they will actually save your life. I'm going to try to see if in the book here they do have exponent rules, and if they don't, then you might need to remember them. But essentially, going down here, I don't think I'm able to see. No, I'm not able to see the exponent rules. I'm going to close this guy. The exponent rules say that if I have a power, so if I have something like a to the m to the n, this is the same as a to the n to the m, which is the same as a to the m times n. Beautiful. So a to the power of m to the n, that's going to be what you get. Fine. So using this rule, I know that my m can be 3 and my n is going to be x. So I can rewrite this whole thing. Actually, I should have not erased that. I'm going to put this guy on the side. Using this guy, I'm going to write 10 to the power of 3x is equal to 10 to the power of 1/3. And just like above, we're going to be looking at the base are the same. So we're going to be looking at the exponents, how they relate to each other. So I have 3x is equal to 1/3. And I'm going to try to solve for x. What do? I can divide both sides by 3. So I'm just going to do this whole thing. And when I divide, so I'm going to put x is equal to 1/3 over 3. This guy, we multiply. Or for some of you, you want to use the keep change flip, which is going to be essentially x is equal to 1/3 times, this is the same as 3/1. So I keep this one on top and I change this one. So I flip. I've changed, so I keep, I change this, I change the division to a multiplication. And then I flip the other side, so it's gonna be 3/1, it's gonna be 1/3, which gives me 3 times 3 gives me 9. 1 times 1 gives me 1. So I end up with x is equal to 1 over 9. Perfect. And that is how you do it. And that is how you do it. There was so many things to cover here, but the most important thing is to realize that we don't like logarithms. We would rather work with exponents for most of the cases. Even as a math major, I would rather just work with exponents, even though they are really terrible at scaling. But they actually do help a lot. So that's how you solve this type of problems. That's how you solve this type of problem. And so that's all for today. If you enjoyed this or learned something new, don't forget to like, subscribe, and tap that little bell so that you won't miss any of the next episode. I try my best to publish at least 2 every Friday starting now, and so I hope that you really like it. And please share it with your friends and those people who actually need it for IB. I've been there. I know it's challenging, but I'm pretty sure you can do it. So have a nice rest of your day. Thank you.